tried those two problems for C and D, it did work. How did you find the eigenfunction? Which eigenfunction you have taken? Let's see whether you understood properly or not. For C problem was d to u by dx square minus du dx, something like that. Okay. What eigenfunction, which operator eigenfunction you took? Which operator eigenfunction you took? Because this operator is a self-adjoint operator. Okay. Then which operator eigenfunction you take? See, basically your solution is u equals to summation ci phi. These phi are the eigenfunctions. Okay. These phi are the eigenfunctions. So my question is, which operator eigenfunction you will take? Operator L. What is that? Stam will be fine. Operator, which operator? That L operator stam will be coming. And those, see, when you find the eigenfunction, you don't need the stam derivative. Only we need the stam derivative to find the weighting function, right? Up to it. Otherwise, you don't need. Because eigenfunction will be automatically coming without stam derivative. The stam derivative you need only when you want to know what is the weighted inner product. In that case, that will be useful for the, if we talk about the stam derivative. The question is, what is the situation here? See, if you look at adjoint theorem, is very important. Always you should, first thing you should do in your finite Fourier transformation, write this formula JUV plus U L star V. Am I correct? This is the first thing you have to do. That we have learned long back. This is not a difficult thing. That we have learned long back. Now what is the, this V is what for our case? E is what? V is the eigenfunction. So V is nothing but eigenfunction. Remember that when you operate, it will be coming as L star phi. It will be coming as L star psi. Okay? And what you did next step? You did LUV, JUV plus U lambda W whatever V. And why you could do? Because L equals to L star. If not, what will happen? Because for this case L is not equal to L star, right? For this case L is not equal to L star. What will happen? Then what will be the eigen? So the question is, if the operator is not self-adjoint, what will be the eigenvalue problem? See, after doing that, next step will be the eigenvalue problem. What is the eigenvalue problem in that case? I am talking of the eigenvalue problem in the case where L is not equals to L star. If L is not equals to L star, what is the eigenvalue problem? For example, let me see our problem set 7. Do you have the problem set 7 handy? Problem set 7. 4C and 4D, those two problems I am talking about. d to u by dx square, d to u by dx square minus du dx equals to x. I am saying 4D. The boundary conditions are very straightforward. u0 equals to 0, u1 equals to 0. In this case, you don't have any problem. Boundary conditions go so straightforward. Now, the question is, what is the eigenvalue problem? Because in finite Fourier transformation, once you identify correct the eigenvalue problem, 90% of your problem is done. 90% of your problem has been done. This is a very important step. If you don't do it properly, the entire problem is wrong. If you do it here, at least 80% you are correct. You should deserve 80% credit. What is the eigenvalue problem? Remember that when you do this one, LUV, so what will be the things? LU psi I, JU psi I, U lambda W psi I. this lambda means what? Eigenvalue of what? This lambda is eigenvalue of what? What is that? What? Don't say stably, because you know that term doesn't mean that you will. What you are saying is lambda is what? Lambda is what? What definition of lambda? Tell me. Don't say stably. Lambda is eigenvalue of which operator? L star. Don't say adjoint at all. You know all the terms and just look at what is actually happening. It is quite obvious that if you put L star psi equals to lambda W psi, that means lambda has to be the eigenvalue of the L star and psi is the eigenfunction of L star. That means when you talk about this psi has to be the eigenfunction of L star. Most of the cases we are seeing L equals to L star. If L is not equals to L star, then you have to find out what is L star. The next question is, what is L star? Did you find out from adjoint? What is L star? What is that? d2 d square plus d plus d dx. So what is the eigenvalue problem? d2 psi I dx square plus d psi I dx. This I should be very important. Other last class it was mixed up psi I and n, please in place of n you put I. Okay? Equals to what? What is the weighting function here? Okay, that will come later because we both say minus x. So this will give the eigenvalue problem. What's that? So remember that whoever will do minus here, it will be wrong. This is the eigenvalue problem. So remember this catch. L star b. This is actually giving this. If you cannot substitute properly, you won't get this cube relationship. If you don't, then you have a problem. Because you have to find out Ci. And what is Ci? Ci is nothing but Ui. If I write in terms of orthonormal eigenfunctions, it is inner product U phi I. Where phi I are the orthonormal eigenfunction. Psi I are the orthogonal eigenfunction and the phi I are the orthonormal eigenfunction. Right? Phi I are the orthonormal eigenfunctions. Okay. So what are the psi I then in that case? What is psi I? And your boundary condition you have to write. It is psi I at x equals to 0 equals to 0 and psi I at 1 equals to 0. Very simple boundary condition. A very simple problem though. Very simple problem though. Okay. What you finally got? The psi I. What is that? There are two terms, and if you put the boundary condition, what is the final you are getting? Don't ask me to do all those things. You have done so many times. This is too much actually if I do it again. We have done the regular class. We have done the regular class also. This problem I have discussed for eigenfunction expansion. So please don't ask me. What is psi I then? We have done in the class. What is that? Nobody is telling. I am telling. That's why I am telling. Which people I am teaching in the class, I don't know. These things were discussed in the class so many times. People are just buzzing. No answer I am getting. No answer I am getting. Nikita, what is happening? You can't solve this problem? A to the power x by 2. Then Bn or Bi. See, that's the problem. You have some formula marking business. With this marking business, you are actually doing the problem. Bi e to the power x by 2 sin I by x. That's all. Done? Okay. This is the orthogonal eigenfunction. Remember that I and n, that confusion should not be there. It should be I. Straightforward. Because if you have any problem, you see our eigenvalue problem for the vector space. What is lambda I u1? If you remember that, everything should be in accord with this relationship, this form. Okay. What is the problem first bench? Any problem? Any problem you can ask me. I may give it an answer. What she must be given? Minus x by 2 or plus x by 2? So that's what I'm saying. Even these problems are not telling me correctly. Yes, if you have any problem, you just clarify in the class, you can verify because I don't have the answer with me. E to the minus x by 2 is correct? Only 2-3 people are confirming, other people are not even confirming what a level of the class. Okay? So, e to the minus x by sin pi I pi x. So, what is the phi I then? This is orthonormal eigenfunction. Did you do this way? You have done wrong then. Yes, I knew that in between this carries the cat. I told last time, last class. You just that's the problem because most of the time you actually put the formula and put the value in the formula and get the result. This class is not that. It's a derivation based class. If this is a derivation based class because in research we don't put the value in the formula. We derive the things in the theoretical research. Okay, phi I. What is the orthonormal situation? Orthonormal means this psi I divided by norm of psi I in the domain 0 to 1. Domain is defined. How much it is coming? How much it is coming? Because once you understand this kind of problem, we can solve many problems. Many such problems. What is phi I? This also you cannot do. Psi I, it is nothing but psi I divided by norm of psi I, which is pi e to the power minus x by 2 sin I phi x divided by integral 0 to 1 pi e to the power minus x by 2 sin I phi x whole square dx whole to the power of. This is by integration by parts. Integration by parts can you do? You do integration by parts. You could have done actually when you are doing it. This problem at least you could have come up to this point. Yeah, how much it is integration by parts? If you do that, what's the orthonormal function? That's why I'm not doing in the class all these assignment problems because you guys are not interested. Only 2-3 guys are doing regularly. Only 2-3 guys. Only 2-3 guys are doing. How much? 5. No answer, no? Why I'm surprised which class I am teaching. I am teaching 10 plus integration by parts. Only 3 people are doing, I guess. What happened? I told you that practice the weekend. What is the situation? What is that? You know, this integration by parts only you know that only 2 things are there. This and this. I am not asking 3 functions. Only 2 things are there. Vi and Vi will get cancelled, no? Only these 2 things are there. How much it is? Nobody is giving, I am also standing. Why to teach? My God, I am really surprised that in the entire class people cannot do the integration by parts. Yes, first bench madam. Have you got anything? What is pi r, orthonormal eigenfunction? What you got? Root 2? Root 2, then e to the power minus x by 2. Yeah, that is the actual function. The root 2 is the factor coming. Is it correct? I am asking a question. No, what is the answer? You are now saying something different. At least you are saying something, but nobody else is giving anything. That's why I am surprised. The class of 60 people. Class of 60 people. And I don't know whom I am teaching. Class of 60 people, everybody is silent. Simple integration by parts, if you cannot know how to do in the end semester, we won't give 6 hours for the end semester, only 3 hours. And you should not spend so much of time. Vasudha, you also cannot do integration by parts. What are you doing? That's why I told in the last class, these problems are I want the solution. What are you doing? I am not giving some problem which I have not told actually. At least one person gave the answer. Nikita, you also don't know how to do addition by parts, huh? First bench, Amit. What are you doing? You are saying doing integration by parts. What I will do actually, I will teach this class with the one-on-one school 10+2 people. We will see who is better. Next time I will invite those people. This idea is a very good idea. So 4 or 5 toppers actually I will put in the class. And I can tell you they can respond better. One-on-one KV school people actually I will put here in the class. At least I can teach something better to them. They are interested. Because I am sure KV guys will do better, faster. I cannot teach this way. And you are looking at his notebook, right? No, I put the next time, you know what I put on KV school fellow, you will see the KV school fellow's notebook. Next time. So that is not what we know. So one of you and next to you one KV school guy will be there. That is the best combination. If you have any doubts, you can ask that guy. That guy will be very prompt. That is a good idea. At least you will get some competition. You have to show that you are better than KV school guy. So you will do the work. Master, you are struggling. You don't know how to do integration by parts, huh? That's what I am saying. What level I am teaching, I don't know. What is the proper integration by parts? Which is u, which is v? Integral u v dx equals to u integral v dx minus integral du dx integral v dx whole dx. That is the formula. 0 to 1 limit. Where is the problem now? What is u? What is v? What is u? Tell me. U is what? Sin square what? Sin square I by x. What is that? Why you get sin square I by x 1 cos 2 pi x 2 I by x. Yeah. So there are two terms, 1 minus cos 2. That first term is very easy. I am not considering the first term. Second term, what is the problem? What is u and v in the cos? E to the power x, e to the power minus x by 2 whole square. It will be what? E to the power minus x only. So straightforward. What is the problem then? Pardon? Pardon? Weighting function, yes. Yeah, weighting function also be there, yes. E to the power, what is the weighting function? E to the power minus x. Then? Then how much is your minus 2x? I don't know, I want the answer. So basically what actually you have to do here, instead of psi I, you have to put phi I, because you are doing orthonormal eigenfunction. Okay? So I hope we'll be doing this part. Remember that whatever inner product we'll be taking, that is based on weighted inner product. Because weighting function is not one here, it is having something. There also you can do some mistakes here. Somebody was doing mistake. Okay, so I'm not going to discuss this full problem because you are not interested. But exam, this type of problems are given and you will be suffering. And I tell you that I have discussed your class situation in the department, and I was told that even I can start the maximum grade C. I was told that, so no problem. Then we are having a faculty meeting for the current NTech scenario. We are very much concerned about the performance, and I was told that if the guys are not interested, I can give the starting grade from C. You can get to C, D, E, because I am not going to give any U grade. So it looks like that massively people will get E grade. And I can tell you that if you get 2 E grades, MTech guys, your scholarship will be hard. Just for your information. So if you are not practicing here, you will suffer. I cannot help it. But whatever I am teaching in the class, I will be giving from that. I won't give anything outside by the class notes. But still I can tell you that last bench, what is the situation? You didn't get anything, right? Yeah, what for you are coming to the class, you don't know. That's right. So you see, it looks like that people are not interested. They are fully saying that I am not doing anything. So in that case, why should I put fight here in the class? Okay? So that is your future, not my future. And of course, some of you guys will be leaving after the gate exam. So there is no point to shout. So I don't want to discuss that part. If Basudha wants, you can submit. It is your choice, not my choice. Even I don't insist. If you say I don't want to submit, it will be excellent for me because I don't waste my time. So LU is now my main problem is LU equals to A. So what we'll get last step, F phi I, which is JU phi I. To put your phi I, everything should be in terms of phi I because we are talking about the normal eigenfunction, and here it will be U, that is, you have lambda U phi I with respect to weighting function. Remember that. With respect to weighting function will be coming here. This is very, very important, otherwise you get wrong results. This is a respective weighting function, and this weighting function is coming here. Right? So, and what is the thing you want? You have to find out U phi I, and definitely this is also with respect to weighting function. So the weighting function is non 1. That means the weighting function value is not 1. Whenever we are actually using the inner product, we have to use weighting function. That means your Ci is nothing but inner product U phi I Wx with respect to Wx. Okay? So this is coming from here. So you have to find out this is your Ci, and Ci will be what? F phi I minus Ju phi I divided by lambda, which is your C. That's the final solution. And once you have the final solution, you put it here, you get the final form. So that's the Farad's transformation. So I wanted to show you how to get phi I, but you are not interested, so better not to talk on that part. Okay, so I think another part is slight mistake here. It should be minus lambda, right? It should be, if you put here, it should be minus lambda because the eigenvalue problem is x star phi I equals to minus lambda w phi. So minus sign will be there. So it will be f phi I this class. That's all. Slight mistake. So I have given the entire, again I have discussed the entire procedure. It's like a repeat to the last class. Maybe one or two guys will be interested. You can look into it, otherwise forget it. So let's look at the partial differential equation what we are talking last class. So first we'll be talking about the partial differential equation, the one space which is parabolic, and then we'll be talking about a two-dimensional elliptic problem. So let's look at our problem what we are discussing, rho to u rho x square plus is a parabolic PDE, dou u dou t equals dou t by dou x square equals plus fx, which is ux equals to 0, u0x, you have u0t which is G2. What does it mean? This means that x equals to 0, x equals to 1, and the boundary condition. What actually happens generally is we think the boundary condition are constant. Sometimes boundary condition will change with time. For example, heating rate, for example, changing with time. So in that case, of course, this kind of non-homogeneous differential equation, this kind of problem will be a big failure if you want to solve by separation of variables. But when you want to solve by finite transformation, doesn't matter what kind of boundary condition you use, and that could be solved. So last class, what we are doing that. So we found the first we have to find the eigenvalue problem, and this type of problem is pretty straightforward because if you look at the x, so here the eigenvalue problem, remember that will be the space. Then here only one space is there. Then we have only one eigenfunction. If there are two spaces, you get two eigenfunctions. And eigenvalue problem by space, in that case, identify what is the space operator, which is dou 2 by dou x square, which is by default the self-adjoint operator, right? Which is by default the self-adjoint operator. So in that case, what actually happened? Your x direction, the eigenvalue problem is this one. X direction eigenvalue problem is this: d2 psi I by dx square equals to minus lambda I psi I, and the boundary conditions will be the similar boundary operator, which is psi I 0 equals to 0 and psi I 1 equals to 0. Dirichlet operator is also Dirichlet operator. And for that, we found out phi I already, which is root 2 sine I pi x, which is root 2 sine I pi x, right? So phi I we found that root 2 sine I pi x. Now, what is the situation? As we said, so once you find the eigenvalue, once you found the eigenvalue problem, we can write our differential equation, dou u dou t, which is dou 2u by dou x square plus fx. And what we do, take the inner product with respect to phi I, 0 to 1, dou u dou t, phi I x dx. Remember that wx equals to 1. Remember that wx equals to 1. Whatever inner product will do to the finite transformation, first thing you write your notes, you just write the statement. Whatever we do inner product, wx has to be always taken care. If you don't remember, we will do big mistakes. Okay. 0 to 1, dou 2u by dou x square, phi I x dx, plus 0 to 1, fx, phi I x dx. Okay? And what kind of solution we will be getting here? U equals to summation, we have discussed other day, CIT phi I x dx, and U is the function of x and t. And Ci here, since this phi I is based on the self-adjoint operator, your Ci is nothing but U phi I x wx equals to 1. Always you write wx better. I want to do that way, wx equals to 1, because it creates a problem. Okay, so what actually happens, I say the first type integral is the type 1. Type 1 integral. Type 2 integral, this will lead to the further operation, and those operations actually is the adjoint theorem. And what actually term will lead to? Type 2, we have discussed in the last class. Type 2, final form should give it to me. Type 2, type 2 the final thing you have to give it to me. Minus G2t phi I prime 1 G1t phi I prime 0 minus lambda I u. Am I correct? Yes. So type 2 is actually over. Type 3 is also straightforward. So what you currently got? I defined ET, which is integral u phi inner product u phi I x wx, but wx equals to 1. So I can write this as, so if you substitute so what we can actually get? So u is the function of x and t and phi x. So you can directly write dou dou t of integral u phi x, because phi x is not the function of t. So phi x will act as constant with respect to t. So we can write this as d dt of pt. Can I write? Because this has integral everything. Can I write d dt pt plus now second term will give what? So this is also wx and this is nothing but your pt. So what you are getting then? Plus lambda I pt equals to qt. What is qt? You tell me what is qt. So this entire equation now lead to a very simple equation, which is dy dx plus py equals to q, which you have solved using integrating factor. What is qt then? What is qt? What is qt? What is qt? qt minus d2t 5 I prime t x, then 5 and 1, right? Plus g1t phi I prime 0 fx phi ix with respect to wx. With respect to wx. Now I feel after solving this you have the clear cut concept for solving the 4C and 4D problems. Okay. Now next step. This solution part I will not discuss because I have discussed already. How to solve it? What is the integrating factor? IF e to the power minus. That's what I am saying. Arbitrarily, let's say e to the power lambda it. Okay. Next step. What is the next step then? Once you fix up the integrating factor, what will you do? Multiply all the sides. So it is e to the power lambda it ddt of pt plus lambda I e to the power lambda it pt e to the power lambda it qt. This will give what? ddt of pt e to the power lambda it equals to the power lambda it qt. Next step is differential of pt e to the power lambda it e to the power lambda it qt dt. Next step. Integral plus c. What is that? pt equals to, if you say 0 to t to the power, then what? 0 to t e to the power what? What are you saying? That's what I'm saying. Whatever I keep saying thing again and again, you will be doing the same mistake. That's what my job is, to teach same thing. Your job is to do the same mistakes. That is the way. How to write this? This we have done so many times from the very beginning. Dummy. Did I say dummy variable? I could have said that also. I am telling this country sometimes you say private college or teachers are bad. Even I am teaching well, how does it matter? Doesn't matter. What is that? What? U of tau. Q of tau. How it is coming here? First see the form. Don't try to mug up. Use your brain. You have the brain. You have brain. You apply the brain. You can get it. You have the brain. Don't try to mug up. If you mug, you cannot do maths. You look at the board. If I put a limit, what will happen? I don't know how many times. If I say, can I write like this? Now I am asking this question. Can I write like this? If I say 0 to x, what will happen here? What will happen? What should I write? It is not correct expression. In the gate they can actually give this, is this correct? You will say, no, what is the correct expression I am asking? What is the correct expression? Many people are saying, but I am not getting correct answer. What is the correct expression? This is the level of my teaching today. What is that? Please, somebody volunteers, please. Integral 0 to x. That's the equivalent form. So, you tell me the answer. See the level. Every time I am doing the same kind of thing, you are doing different kind of thing. What is that? What is that? I am really surprised what every step I have to stop in the class. What class I am teaching? Every step I am stopping. Everybody is putting like this. What is the answer? I get the answer here. What is the thing? Up to this everything is clear. What q of t first? This term will not be there. That means you are not comfortable with this term. That's why you are saying all the time q of t, q of t. First of all, q of t will not be there. It will be q of tau. E to the power lambda I. Tau minus ts. Q of tau. D tau plus c lambda I. D. Okay, next step. So it will be e u phi x w x 0 to b e to the power lambda I. You can directly write e to the power lambda I tau, 2 tau, d tau, e to the power minus lambda I t, c e to the power minus lambda I. Now the situation is you have to find out the value of c. How to find c? How to find c? If you cannot find c, then the problem is gone. How to find c? And don't get confused with c and ci. Ci is different and c is the integration constant here. This c is integration constant. How to find c? So now apply the initial condition. At t equals to 0, what actually happens? At t equals to 0, this integration vanishes, right? 0 to 0. So at t equals to 0, what actually happened? U will be u0. It is given there. So it is u0 phi ix wx. This is gone. Equals to e to the c e to the power minus lambda I t. T0 equals to 1. C. So c equals to this. Okay. So what is your So what is the answer then? Integral u phi x equals to integral u phi x equals to 0 to t e to the power lambda I tau q tau d tau e to the power lambda I t plus u0 phi ix e to the power minus lambda I t. That is equals to your ci. Am I correct? This one? Okay. So this is your ci. Okay. So this part is very crucial. You have to find ci and then the point is next is your solution. Your solution is it is summation I equals to 1 to infinity ci phi ix. And how many terms will be taking? Roughly 20 terms. But for the exam purpose, 5 to 6 terms will be okay. You have to show the convergence. So this Ci. So Ci actually, so that means Ci means you have to change your I values, lambda 1, lambda 2, lambda 3, lambda 4, so on. Usually is constant given. Okay? And Q itself is a very complicated stuff. Q has the term. What is Q term? Let's look at Q tau will be minus G2 tau U phi I prime 1 plus G1 tau phi I prime 0 plus inner product phi Ix with respect to the British. Correct? Okay. So this Q tau is also a function of i's. You can see that these i's are actually coming. So this has the three integral terms. First integral term is this. Second integral term is this. Third integral term is this. G2 tau is a function of tau. Okay. So tau e to the power lambda I tau phi I prime 1. It is mostly a constant, right? It is also a constant. So it will be done by division by parts. It will be done by division by parts. And fx phi ix wx, this term is also a constant in the integral. So this term will be having only one term, which is called lambda I tau. So this is the way in the exam you have to evaluate each term by term, right? And that's it. Job is done. Once you do it, any kind of problem you can solve it. And application of this, if you want to know how the things are actually applied, as I told you that AICG Journal 2009, Bhattacharya and Basak. This paper, please refer. This is the only paper in chemical engineering literature on finite fluid transformation. This is the only paper in chemical engineering journal. We can see the reference and Bhattacharya and Basak in AICG Journal 2009. Next problem we will be taking, the last problem. We will be taking on the elliptic operator, two-dimensional space with a parabolic operator. So what will increase? We will increase the one space. We will increase the space here. So rho u dou t equals to rho 2u by dou x square plus rho 2u by dou y square plus function xy. Very complicated. Okay. This type of problem quite often you see in microwave heating, for example. We have the time dependency of temperature, space dependency, and this is the microwave heat generation term. Okay. The typical problem for the microwave heating. Okay. So u xy is 0, u0 xy, u0 yt, g1 yt, u8 yt, which is g2 yt, ux0 t, which is h1 xt, and which xbt, h2 xt. What I am saying that we are solving this problem in a domain in the x direction. The domain size is a, and y direction the domain size is. Most generalized problem in the heat transfer. So we have got heat generation term. Generation term could be complicated term, and we have the time dependency, and the boundary conditions also changing with time. Boundary conditions are also changing with time. How to solve? And this type of problem, if somebody sees, they will say, oh, okay, this kind of problem cannot be solved by analytical way. The answer is yes. This can be solved by analytical way. The answer is FFT, finite Fourier transformation. The answer is finite Fourier transformation. So now the question is how to solve this type of problem. What are the, how many eigenfunctions will be there? There are two eigenfunctions. There are two eigenfunctions. First eigenfunction. What is the solution for formulation of the first eigenfunction? Quick. We first finish the eigenfunction, next class will be doing the entire problem. First eigenfunction. D square psi x comma I should be divided by dx square equals to minus lambda x psi x comma I. And remember that in the x direction, operator itself at wx equals to 1. Similarly, so here the boundary operator is division operator, you can see that. So psi x comma I 0 equals to 0 and psi x comma I x a, right? Similarly for y direction, d2 psi y comma j, remember that. Same index, dummy index you cannot apply. D square psi j equals to minus lambda yj psi yj, then psi yj 0 equals to 0 and psi yj b equals to 0. So we can see that we have done the partial differential equation. We have shown you that same dummy variable you cannot use the same both the directions. So tomorrow's Friday's class, what we will do that we will start from here, finish finite weight transformation. I will also show you some of the adjoint theorem applications. These are all applications of the adjoint theorem. I will show you how it can be applied to Green's function, very big applications. And next week onwards, we will be doing numerical analysis. So analytical class will be over by this week. Thanks for attention.